Hello and welcome to another video. In this video we're going to be working on evaluate Boolean binary tree. And it's a pretty easy one. You're given the root of a binary tree with the following properties. Leaf nodes have a value 0 or 1, where 0 represents false and 1 represents true. And non-leaf nodes have a 2 or a 3, where 2 represents or and 3 represents and. The evaluation of a node is as follows. If the root is a leaf node, it's true or false. Otherwise, you just do the Boolean operation and you want to return the Boolean of evaluating up to the root. And so every tree is full, which means every node has 0 or 2 children. So in this example, basically what's going to happen here is false and true evaluates to true or false. And then false or true evaluates to true. So this should be true. This leaf node is just false, so you just want to return false. So it's pretty easy. All we have to do is we can just recurse. So we can just say, like, if the node's value is 0 or 1, return true or false. Otherwise, get the left or the right. So basically we could say, like, okay, this is not 0 or 1, so let's go left, let's go left, let's go left. So here we'll return false. Then here we'll return true. And then we'll just check, okay, what's false and true? Because we can just check for, is it a 2 or a 3? If it's a 3, we'll do an and. So here we're going to return false. Then we're going to go up here, check the right child. So same thing, we're going to have 0. So this is false and false. So we have false or false. So we would return false. And then what's false and false? False. And then we're going to recurse right, go down here, go down here. This is true, so this is true. So this the whole thing would return true. Then similarly, this is true and this is false. So true or false would give you true. And so we have true and true, so we get true. Then we get true and false, so we return true. So pretty easy. You just have 4 if statements, like what's your value? If it's 0 or 1, return the Boolean. If it's a 2, do an and of the left and the right. Or do an or of the left and the right. Then if it's a 3, do an and of the left and the right. Really easy code, really easy stuff. Just take your value and do the Boolean operation. Just do a basic DFS. So let's do that. So we can even just write it right in here. So we can just say if root value equals 0, let's return false. Then if it's 1, let's return true. Otherwise, we're going to get the children because we know it has children because it's a full binary tree. So we know it has children for sure. So we can just say like Boolean left equals evaluate tree root left. Same thing for the right. Now we just check for the other 2 values. So if root value equals 2, so this is the or operation, so we can just return left or right. And finally, the last case is the 3, so we just return left and right. And basically, it's a very simple problem. Return. Okay. Used to Python. And there we go. So there we go, pretty easy. So basic DFS. So we can talk about time and space and all that as usual for all DFS. Time is O of n, where n is the number of nodes. Space is, you can either say O of n worst case, or you could say O of height, where height is the height of the tree. Worst case height is going to be O of n as always. If you're actually, so here this tree is perfectly balanced. So what's the worst kind of tree we can have? Like, let's think about it. I think we can still have like a pretty bad tree. So let's say our tree looks like this. So this like this. Now this can't have 1 node, but it can have 2. And now this looks like this. And we just keep doing this, right? So I believe this is like a valid tree. So something like this would basically just keep like, it's not like completely one-sided, but it's basically, so this would still be like a balanced tree. So let's look at the definition actually for their balanced tree. Or sorry, it's not balanced, it's a full binary tree, yeah. So every node does have 0, 2 children, so it'd look like this. There. Now every node has 0, 2 children, so every node has 0, 2, but it's still not like a balanced tree. So worst case, this would basically be O of n height, right? Like we have 11 nodes, and the height is 6. So if you just keep repeating in this pattern, right? This would be basically O of n. So you could say it's O of h, where it's the height, or O of n, where n is like the worst case scenario. Either one, pretty reasonable. Yeah. And on average case, it's going to be O of h, which is the height, which is like a balanced tree would be actually log n. So if this tree was completely balanced or close to it, if it was just like this, just like a really big tree like this would be log n. Because basically every layer you get another, your tree doubles in size, which is log n. So yeah, pretty simple, not too much here. So if this was helpful, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.